This lesson is over visualizing domain and range from a graph. Now recall, domain of a graph can be described as all x values for which the graph is defined. X values refer to the x-axis, which goes from left to right. In other words, how far left and how far right does the graph go? Recall, the range of a graph can be described as all y values for which the graph is defined. Y values refer to the y-axis, which goes from down and up. In other words, how far down and how far up does the graph go? Example 1. Determine the domain and range from the graph. Write the solution in interval notation. Now take a moment to look at the graph. Notice, because of the arrows, we expect the graph to continue in that direction for forever. Let's start by looking at the domain. Domain corresponds to the x values, which means to look along the x-axis. We have to write this in interval notation, which means it must be smallest to largest. So we will start looking along the left side of the x-axis. As you travel to the left along the red line, what's the furthest left you ever see? Well, because it has an arrow, that means it continues for forever and ever, which means it will be negative infinity, which means we will use a parenthesis. Now as we travel to the right along the graph, along the x-axis, what do you notice along the right side of the red line? Well, at the end you see another arrow, which means it continues for forever, which would be a positive infinity, which we must use a parenthesis. Now for our range, your range corresponds to your y values, which is your y-axis, or how far up and how far down. Because we must use interval notation, it must be smallest to largest. Well, we find the smallest values on the x-axis as you go down the graph. So as you look down along the y-axis, what's the smallest your graph, the red line, will ever go? Well, because you see an arrow, that means it continues for forever, which in this case would give us negative infinity, where we must use a parenthesis. Now we're ready to find the largest value, which means we travel up along the y-axis, and as we follow the red line up, we notice we have another arrow, which means it will be infinity, and again, we must use a parenthesis. Example 2. Determine the domain and range from the graph. Write the solution in interval notation. Well, first we're looking for the domain. Domain means x values, which means we're going to look at the x-axis, which goes from left to right. So look at the graph and see what's the furthest left our graph goes. Notice you see an arrow, which means it continues to the left for forever, which would tell us negative infinity. And we must use a parenthesis anytime we use infinity. Now we travel along the x-axis to the right, and what do you notice? Well, our graph has another arrow, which means it continues for forever, which again would be infinity. And then we must use a parenthesis. Now time to look for our range. Range corresponds to the y values, which means the y-axis, which travels up and down. Because we must write interval notation from smallest to largest, we have to look at the lowest part our graph ever goes along the y-axis. So as you follow the red line down along the graph, what do you notice is at the lowest point? Well, because you see an arrow that indicates negative infinity. Now, as you travel up along the graph, what do you notice? At the top end of the graph, you see another arrow, which means it will continue to positive infinity. So that is your interval notation. Example 3, again, we're being asked to find the domain and range. Again, domain means x values, which means we're going to look along the x-axis, which travels left and right. So as you follow your graph to the left, what do you notice? Well, you see an arrow, and because you see an arrow, it means infinity is somehow involved. Because it's on the left side, that will mean negative infinity. Now, as we travel to the right along the graph, what do you notice? Another arrow, which means it will be infinity again. For the range, we need to think of the y values, which means the y-axis, which travels up and down. So as you look down along the graph, what do you notice? Well, you see arrows, and because it's on the lower part, it means it will be negative infinity. Now, as you travel up along the graph, what's the highest your graph ever goes along the y-axis? Notice, it is a 0 this time. Now, can we include 0? Well, look specifically at that point. Is that an open circle or a closed circle? Well, since it is closed and we see the ordered pair 0, 0, that means it is included, so we would use a bracket at the value of 0. This is your try it problem. Let's see how you did. The domain should have been from negative infinity to positive infinity. The range should be bracket -3 to positive infinity. Example 5. Again, we're being asked to identify the domain and range. Now the domain means the x values, which means we're going to follow the x-axis. So we look how far left and how far right. As you look to the left, you see an arrow, which means negative infinity. As you look to the right, you see another arrow, which indicates positive infinity. Now we look to our range. Range corresponds to your y values along your y-axis, which means how far down and up your graph goes. But notice, this graph is a little different. What value does the graph tend to be at? Well, it looks to be at -2. But the difference is this doesn't change from the whole entire graph. Y is always at -2. Now, when you only have one value, such as this, you cannot use brackets or parentheses. Instead, you must use a different grouping symbol known as braces. So that would be your range